All right, chapter 6, lesson 43 is going to be on graphing and domain of exponential functions. So when you graph an exponential function, this is what they will look like. The one that's in red would be anything like 2 to the x, 3 to the x, 4 to the x, 10 to the x. One in blue would be anything that would be where your base is going to be in between 0 and 1, so 1/2, 2/3, 5/19, something along those lines. It's going to end up looking like this, which will come out in the wash when I show you how to work these things. So essentially what you're going to do is you're going to plug in numbers for x, see what comes out for y, and you're going to graph it. When you have exponential functions, again, 2 to the x or 5 to the x, a has to be greater than 0, so you can't have any negative numbers there, and it can't equal 1. 1 to the x would just be a line, because 1 to a power would always just be 1. The reason that negatives don't work is because when you would square a negative, it would become positive, and then you do it to the third, it'd be negative, and then to the fourth would be positive, and it would alternate positive, negative, positive, negative, positive, negative, and it wouldn't make a curve that looks like this. So that's why that has to be greater than 0. So you've got your base and you've got your exponent when you have that. So that's what's going to make an exponential function. All right, so graphing exponential functions. So let's start with the basic one here. Y is equal to, or f of x is equal to the x. What you would do is you would make a chart and you'd plug in numbers for x. So I'm going to do those. I'm going to start from the opposite end down here. I'm going to go bigger numbers first. So if I do 2 to the third, that would be 8. If I do 2 squared, that would be 4. If I do 2 to the first, that would be 2. 2 to the 0 is equal to 1. 2 to the negative 1 is equal to 1/2. 2 to the negative 2 is equal to 1 over 2 squared, so that would be 1/4. All right, 2 to the negative third would be 1/8, and so on. Really, we're going to concentrate on these three numbers, three sets of numbers right here, all right? From with x's being negative 1, 0, and 1. That'll be enough to be able to graph it, but you can use more points if you want to. Okay, so I would take and plot those points, so it would look like this. And then I would sketch the curve. Now notice that none of the y coordinates become negative. 2 to any power, no matter whether you put in a positive number or a negative number for x, you're never going to get a negative number for y. So this thing will never cross the x-axis, so we're going to have an asymptote. So when you graph your exponential functions, you're going to draw in an asymptote. Right, same idea here with f of x is equal to 5 to the x. So in this case, I'm only going to plug in the three numbers. I'm going to plug in negative 1, 0, and 1. So I will get 1/5, 1, and 5. I'm going to plot those 3 points, draw my curve, draw my asymptote, meaning it will not cross the x-axis. So the domain of this thing is going to be all real numbers. Thing stretches left and right forever. And the range is going to be greater than, not greater than or equal to, because it'll never equal 0. It'll just be greater than 0 because, again, you never cross the x-axis on that. For basic exponential functions that you're not shifting, so we're not moving it up, down, left, or right, the domain's always going to be all real numbers, and the range is always going to be greater than 0. If we start shifting it, then your range can possibly change, but on your exponential functions, your domain's always going to be all real numbers. Okay, so when you have your exponential function, your graph will always go through these 3 points, negative 1, comma 1 over the base. It'll always go through 0, 1. It'll always go through 1, comma the base. So if this were 6 to the x, it would go through negative 1, comma 1/6, 0, 1, and 1, comma 6. You'll have an asymptote at y is equal to 0, and your domain is going to be all real numbers, and your range will be greater than 0. This would be a good thing to have in front of you as you're doing some of the problems. Okay, so the previous thing said that there wouldn't, that those things apply when you don't shift. Well, what happens when you do, okay, when you add or subtract numbers or you multiply by a negative. All right, so if I take and add a 1 or any number at the end here, not in the exponent, but at the end, I guess you could have it before it too. You could write this as 1 plus 3 to the x. It would be the same thing as 3 to the x plus 1. So anytime you add or subtract a number, that is going to shift your graph up or down. Positive would go up, negative would go down. If you add or subtract in the exponent, that is going to shift it left and right. It's going to go opposite of what you think. Plus is going to move it to the left. Negative is going to move it to the right. Just like it was when we did, say, y is equal to x squared, and we did then x plus 1 squared. That moved it to the left one spot. Same idea here. If you take and multiply the front by a negative, now, at the beginning I said you can't have your base be negative, but this is not a negative base. This is 3 to the x multiplied by negative 1. This is not negative 3 to the x. That's different. That's not exponential, and you can't do that. This is actually 3 to the x times negative 1. That will reflect it over the x-axis. So there is a difference between this and this. Those two things are not the same, all right? And this one is not exponential, and you can't do it. So this will reflect it over the x-axis. If you multiply your exponent, that will reflect it over the y. Now, you're going to be able to use Desmos to be able to guide you along with this. It'd be nice to know these facts, but if you get confused on any of them, then Desmos would be your way to go about that. So let me show you what each one of these will look like. So these are all based off of the original function of y is equal to 3 to the x. So you'll notice that I graphed that along with each one of the new functions. Okay, so this here in, I guess that's kind of purplish, would be 3 to the x. If I do 3 to the x plus 1, notice how all of the points are shifted up one spot, as well as the asymptote now. So the asymptote now would be at y is equal to 1. So you're never going to cross that. If I'm shifting now to the left one spot, notice how all of those x coordinates shift left over one spot. Asymptote stays in the same spot because I didn't move up or down. Reflecting over the x-axis. So in that case, all of your y coordinates are going to change. You're essentially multiplying what you have here by negative, meaning the y is going to change signs. Asymptote stays in the same spot. Reflecting over the y-axis. All of your x coordinates change in this case. Still have your asymptote here at y is equal to 0. So the only thing that shifts your asymptote is an up and down movement. All right, move it left or right or reflect, asymptote stays in the same spot. Domain and range, again, make sure you're concentrating on those. Like for instance, this one here, when you reflect over the x-axis, this one, domain would still be all real numbers, but the range now would be less than 0 as opposed to greater than 0. So when you're asked domain and range questions, I would take a look at what the graph looks like to be able to come up with that. All right, so you should be able to graph exponential functions with 3 points at least, if not more. Find the domain and range, and then you should be able to translate and reflect. So move it up, down, left, and right, and flip over the axis. All right, so that's lesson 43. Let me know if you have questions.